This is part 3 of the video notes for Objective 3D Graphing Rational Function. In this part of the notes, we're going to review polynomial long division and see how polynomial long division helps us find the slant asymptote of a rational function graph. So for our first example, we're being asked to divide x squared minus 6x plus 7 over x plus 5. So the numerator in this example is the dividend, and we're going to set up a typical division problem where the dividend is inside and the divisor is outside. And polynomial long division goes through the same steps that regular long division goes through, except instead of looking at digits, we're looking at terms. So we're going to see how many times the first term of the divisor goes in evenly to the first term of the dividend. How many times does x go into x squared could be asked, like, what's x squared divided by x? Or x times what will get me x squared? And the solution is x. Now, just like in long division, we want to multiply this and subtract it from the dividend. The difference is now we're multiplying it to a binomial, so we have to do x times x and x times 5. Subtract it from the dividend includes changing the sign of the plus 5x to a minus 5x, and we get negative 11x, and bring down the last term. So next we ask, how many times does x go into negative 11x, or what's negative 11x divided by x, and we get negative 11. Distribute it back to the binomial, to the divisor, and you get negative 11x minus 55. Subtract. And this is the remainder. Well, this is just a review of polynomial long division for the purpose of finding a slant asymptote. So the slant asymptote is y equals x minus 11, and this could be graphed if I were trying to graph this rational function, which I'm not. Let's practice polynomial long division one more time, and then see it in action in a rational function graph. The next division problem is 3x squared plus x minus 2 divided by 2x plus 6. So we're dealing with front coefficients, which means we're going to have to deal with fractions in this problem, but I'm going to go through the same steps for division that I used in the last example. How many times does 2x go into 3x squared? Is the same as asking what's 3x squared divided by 2x. So if you need to, on the side, simplify those monomials, you get 3 halves x. Then we distribute 3 halves x back to the binomial, which gives us 3x squared. And then 3 halves times 6 is 9, so plus 9x. Subtract 1x minus 9x is negative 8x, and bring down the next term. How many times does 2x go into negative 8x? We get negative 4. Distribute and subtract. 22 is the remainder, and 3 halves x minus 4 is the slant asymptote, also known as the quotient. So for our example of graphing, we are going to take a look at the third possible case for horizontal asymptotes, which is actually to not have a horizontal asymptote at all, but to instead replace the horizontal asymptote with a slant asymptote. And so this example is f of x equals x cubed plus 2x squared minus x minus 2, all over x squared plus 6x plus 8. While I set up my graph, go ahead and take a stab at factoring the numerator or finding the zeros of the numerator if you're not able to factor. Remember, finding the zeros is an alternative to factoring. Okay. The numerator can be factored by grouping. If you group the first two terms together and the second two terms together, you can take out an x squared, leaving you with x plus 2. And you can take out a -1, leaving you with x plus 2, which gives you the factors x squared minus 1 and x plus 2. Well, x squared minus 1 factors one additional step, and so we're going to have x plus 1, x minus 1, and x plus 2 as our numerator. And our denominator is a simple factor. What multiplies to be 8 and adds to be 6, and that's x plus 4 and x plus 2. From here, you can see that this example has a whole at -2. And we want to go through all of the processes we went through when we were graphing before, starting with the vertical asymptote, which is x equals -4, since that's when the denominator makes 0. Then we have the whole, which is -2, comma. We're going to plug that -2 into the remaining factors. So we get -2 plus 1, -2 minus 1, all over -2 plus 4. That simplifies to 3 over 2. The next thing we have is the horizontal asymptote. And the horizontal asymptote needs to be a polynomial long division problem. You can start from the original, but it's usually better to go from the simplified version back into standard form. So actually, let's pause on horizontal, go ahead and do our x-intercept, which is when the numerator equals 0, or -1 and +1. And our y-intercept is when we plug in 0, and that's going to give us 0 plus 1, 0 minus 1, over 0 plus 4, which is -1/4. It's now time to find the horizontal asymptote using polynomial long division. So the first thing we need our simplified problem back into standard form, and that's going to be x squared plus 1x minus 1x minus 1, and that simplifies to be x squared plus 0x minus 1. Normally, I wouldn't write the 0x, but for division, I need placeholders. So I'm going to rewrite this as x squared plus 0x minus 1 divided by x plus 4. How many times does x go into x squared? X times. X times x is x squared. X times 4 is 4x, and subtract. X squared minus x squared cancels out. 0 minus 4x is -4x, and we can bring down the last term. How many times does x go into -4? X, -4 times. -4x minus -4x is nothing, and -1 minus -16 is 15. Our slant asymptote is y equals x minus 4. Keep in mind that this is not a horizontal asymptote. The horizontal asymptote has been replaced by the slant asymptote. And now I have enough information to graph. So I'm going to do a vertical asymptote through -4. And then a whole at -2, 3/2. And the slant asymptote, I graph just like a normal line. So I'm going to start at down 4, and I'm going to go up 1 and over 1 in a slanted line. And it looks like this is a little bit off the grid provided, so you may want to count your graph by 2s or extend your graph that was provided in the notes, because we need this intersection down here. Then we have an x-intercept at -1, an x-intercept at +1, and a y-intercept at -1/4. Well, these 3 points are pretty clear to connect. We've got a curve that way and a curve that way. The question is, where does the graph lie to the left of the asymptote? So we are going to test -5. And that gives us -5 + 1, -5 - 1 over -5 + 4, which actually simplifies to a whole number, which is -24, which means it's way down here in the bottom corner. And that is the picture of a rational function with a slanted asymptote. This concludes the video notes for Objective 3D, Graphing Rational Functions.